We're going to Google Hypergraph Transfer Protocol. And we're going to click on this link. Hypergraph Transfer Protocol, our new data application layer. In the ever-shifting landscape of technology, our systems are akin to living organisms, especially with the Digi-ID, constantly evolving to adapt to new challenges and opportunities. From the early days of punch cards to the sleek smartphones in our pockets, each leap in technology has been a testament to human ingenuity and the relentless pursuit of progress. Enter HGTP, the Hypergraph Transfer Protocol, a beacon of modern innovation. HGTP is not just an incremental update to existing systems. It's a groundbreaking leap forward, a paradigm shift in how we handle complex data in an increasingly interconnected world. Where did HGTP come from? The Hypergraph Transfer Protocol originated from the Constellation Network. Constellation Network is a technology company that focuses on blockchain and big data processing. They developed HGTP as part of their efforts to create a decentralized network named Hypergraph, which is designed to securely handle and transfer complex data types. The development of HGTP represents an effort to address the challenges of scalability and security in the handling of big data, particularly in decentralized and distributed systems. It's a response to the growing need for more efficient and secure methods of data processing and transfer in various fields, including blockchain technology, autonomous vehicle data, and other large-scale data applications. HGTP is a significant innovation in the realm of data transfer protocols, especially in the context of blockchain and decentralized networks, offering a new approach to handling complex data securely and efficiently. So the people that are saying it's space communication on low Earth orbit satellites pointing down at Earth, or they think they're talking to the Pleiades and Orion. No, you're talking to a software-defined Google system. And the reason for that has directly to do with your digital twin. We looked at this in episode 111. Now let's go back. And we're going to click on the images. You're going to see the multi-semantic hypergraph, constructions of their EEG decoding and encoding. You can see the EEG and coding that we're using for the digital ID. What am I talking about? We're going to search Human Activity Recognition Radar. This image here, this one makes it the most obvious. This is why machine learning and deep learning is using your Hypergraph Transfer Protocol map, because it's easier to transit the data back and forth, and it's easier for the networks to understand what they're looking at. Let's go back. Multi-semantic hypergraph neural network for effective few-shot learning, because your digital twin is using convolutional neural networks and the various formats of artificial networks. Let's click the link and read. Recently, graph-based few-shot learning, FSL, methods exhibit good generalization by mining relations. Mining. Digital data mining. among few samples with graph neural networks. However, most graph-based FSL methods consider only binary relations and ignore the multi-semantic information of global context knowledge. We propose a framework of multi-semantic hypergraph for FSL to explore complex latent high-order multi-semantic relations among a few samples. By mining the complex relationship structure of multi-node and multi-semantics, more refined feature representation can be learned, which yields better classification robustness. Specifically, we construct a novel multi-semantic hypergraph by obtaining associated instances with different semantic features via orthogonal mapping. With the constructed hypergraph, we then develop the hypergraph neural network, along with the novel multi-generation hypergraph message passing, so as to better leverage the complex latent semantic relations among samples. Finally, after a number of generations, the hypernode representations embedded in the learned hypergraph become more accurate for obtaining few-shot prediction. Impressive advances of supervised deep learning have been made in a wide range of areas, whereas such success typically depends on huge amount of data. Supervised. Most of the time, the AI is supervising itself. However, labeled big data may not always be available or easily obtained, which can typically be seen in medical image recognition and terrorist monitoring. In comparison, humans generalize well once having seen a few samples. Hence, it is meaningful to equip a deep model with the ability of learning new concepts from a few labeled data. Few-shot learning, FSL, enabling machines to recognize unseen samples via learning from a few labeled data, has recently attracted much interest in various fields, including computer vision, natural language processing, audio, and speech recognition, and robotics. In FSL, shot means the number of training data points of a class. Owing to the limited or few-shot data, direct training as adopted in common DL methods. For example, mini-batch SGD might be unwise even if fine-tuning on pre-trained models is available. Among the ML-based FSL, graph-based FSL methods become popular due to their capability to link the few numbers of samples with a topological graph structure. Then, with the graph neural network, the latent relations among samples can be learned to help few-shot recognition. For the first time, TPN develops a few-shot learning method based on graph network structure, which jointly learns both parameters of feature embedding and graph construction in an end-to-end manner. Later, some few-shot meta-learning methods based on graph network structure are proposed, which explore the pairwise relationship between samples from distribution relationship, conditional random field, and class level to achieve few-shot image classification. Noteworthy, most of these methods construct graphs to associate few samples via leveraging the binary and pairwise relation. Namely, two samples will be linked if and only if they share the same label, as illustrated in Figure 1a. The topology of your cell structure, whether it's the metamaterials or the artificial neural networks, it's pretty important to them to decide which direction they're going to go next. Now let's go back. And we're going to open this link again. The Hypergraph Transfer Protocol originated from the Constellation Network. What is the constellation network? Let's click on it. We're going to cover this in the next episode.